Cuisinart rods are a collection of rectangular rods of 10 colors. Each color corresponds to a different length. For example, the shortest, which is white, is 1 centimeter, and the longest, which is orange, is 10 centimeters. When they are arranged in what is called a staircase pattern, each rod differs from the next by 1 centimeter. They are used to teach students various topics such as addition, subtraction, multiplication, division, fractions, place value, counting, geometry, measurement, ratios, and area.
One of the basic uses of Cuisinart rods is to provide a model for the numbers 1 to 10. If the white rod is assigned the value of 1, the red rod is assigned the value of 2, because the red rod has the same length as a train of 2 white rods. This pattern is continued all throughout the staircase. As represented, the light green rod represents 3, the purple rod represents 4, the yellow rod represents 5, the dark green rod represents 6, the black rod represents 7, the brown rod represents 8, the blue rod represents 9, and the orange rod represents 10.
Cuisinart rods, because of their different yet related lengths, provide a continuous model for students. This means they allow you to assign a value to one rod and then assign values to the other rods by using the relationship among the rods. For example, a brown rod could represent 8, but could be used to represent a whole when dealing with fractions, which could be for when students are learning fraction conceptual understanding.
Cuisinart rods can be used to develop a wide variety of mathematical ideas at many different levels of complexity. Students use the rods to explore spatial relationships by making flat designs that lie on a table or by making a three-dimensional designs by stacking the rod.
The rods can be arranged to model addition. Some students like to connect them end to end.
So if you take the green rod, which represents 6, and the purple rod, which represents 4, and you add them together, you get the orange rod, which represents 10. So 6 plus 4 equals 10. If you take the red rod, which represents 2, and the green rod, which represents 3, and the yellow rod, which represents 5. You get 2 plus 3 plus 5, which is equal to 10, which is what the orange rod represents.
Cuisinart rods can also be used for subtraction. So for example, if you have 10, which is represented by an orange rod, and you subtract 7, which is represented by a black rod, you can find that 10 minus 7 equals 3, which is represented by a light green rod.
Cuisinart rods can also be used to represent multiplication. For example, the green rod represents 3, and we can use this for the equation 3 times 5.
Cuisinart rods can also be used to model division. So the blue rod, which represents 9, can be modeled by dividing by 3 light green rods, making the equation 9 divided by 3, since there's 3 light green rods. And you can tell that there's 3 spots, making it 3.
For example, 2 plus 3 can be found by first making a train with a red rod, which represents 2, and a light green rod, which represents 3, and then finding the single yellow rod, whose length represents 5. This is equal in length to the 2-rod train. This model corresponds to addition on a number line.
Another example that can be modeled using Cuisenaire rods is 7 plus 4. This can be found by making a train with a black rod that represents 7 and a purple rod which represents 4, and then finding an orange rod which is 10 and a single white rod which is 1. The total of 11 is shown by 1 orange rod and 1 white rod. Another example that can be modeled using Cuisenaire rods is 9 plus 3. This can be found by making a train with the blue rod which represents 9 and a light green rod which represents 3, and then finding an orange rod which is 10 and either 2 single white rods which equals 1 or a red rod which equals 2. The total 12 is demonstrated by 1 orange rod and 2 white rods and or 1 red rod.